There we go. Thank you for reminding me. All right. I'm in Arizona, southern Arizona, about 30 kilometers from the border with Mexico, which is makes it an interesting place because we have a constant a flux of migrants and problem with drug trafficking and so on. But I will just go into light pollution and dark skies instead of our political problems, um, as the title says. And I work with Dark Sky Southern Arizona, the chapter of the Dark Sky International, which was started in Tucson in the 80s. And it's you probably all know about the website darksky.org, which has a lot of useful information. But where I live in a place called Tubec, which is a small community of about 2,000 people. And I also run the Tubec Dark Sky Association here. And a couple of years ago, we succeeded in getting our community to be designated as a dark sky community, which it took two years of preparation, and it's an interesting process. I recommend it for any place that wants to become certified, because it leads to having to have good lighting, outdoor lighting. So anyway, here's the outline, just an overview, our current understanding of the light pollution and how it affects dark skies. And I say the new Dark Sky Southern Arizona because this is a chapter that had gone dormant because people became too old to run it, or some even died. And 3 years ago, we restarted it. And I fell for it. I became the chairman of the board. Um, and I'm going to tell you about a little bit about our regional night sky, because that's what we know here, and I'll show you how we're trying to measure its properties. Oops. And of course, we all know. I don't need to tell you about. I'm hearing myself again. Someone is not muted. Okay. So you can see in the slide, you can see what happens when you have light pollution in an inner city on the left, and moving towards the right. You end up with an excellent dark sky sight. And this is what we like to have everywhere, but of course that's impossible in major cities. And I'll tell you what's happening. Unfortunately, our work has been concerned with the United States and the Western Hemisphere and Europe, so nothing about Africa yet. So I hope connection with Ghana will and beyond in Africa will allow us to say much more about this subject. So light pollution, it can come from below, and what we call ALAN. It's artificial light at night. Any adverse effect or impact attributable to the use of ALAN is light pollution from below. And I'll tell you from above also, and Bruno mentioned the satellite mega constellations. I will talk a little bit about that. This is what happens when you have bad lighting. On the left, you have what we call a light bomb. It's unacceptable, unshielded. Um, Still very bad, and next to it to the right, with some shielding. Still bad, with more shielding. Wow, I'm getting some echoes. Okay, and So
Please,
someone
if
has not.
everyone can mute, yes, if everyone can mute themselves.
I don't know. I don't know. It might be me that's causing.
Yes, we need everyone to mute themselves.
So Silver, Jacob and Jane.
Yeah, I don't know. I'm sure it's us doing it, but I don't know how to do it.
Okay. No, still echoey.
No, that's not right. That's not right.
All right. I think we. No, still. Everyone. Yeah, I can mute everyone by force. You're right. If I can figure it out. I think we're good. Can you all hear me still? Not
Yes.
if you did. Okay. All right. So I'll proceed. And on the all the way to the right, that's the best kind of lighting with full shielding, but also with a timer or motion sensor, because you don't need light on all night, except when there's some activity outdoors. And so in that case, if you have a motion sensor, the light will turn on. It will be nicely shielded, and it will be like this, and that's the best situation. Oops. Light pollution from above, the satellite constellations, SpaceX and Starlink are already, and others. Amazon is getting into the game, and China and Russia. But this is an exposure that shows many tracks of Starlink satellites over our sky here in southern Arizona. For reference, this mountain here is Kitt Peak National Observatory, which has a lot of great telescopes. And of course, satellite trails, they're ugly to see, and you don't see all of them at the same time. That was a long exposure. But if you take exposures of astronomical objects, like this nice galaxy here, you will see trails. And so if you're your object of interest, which say it's a faint galaxy, distant galaxy, it's going to be obliterated by any trail. And there are means to subtract these trails, but what happens is you need to take more data, so you spend more time, you spend more money. So it's a hit regardless of how you look at it. Now, if you think these satellite constellations are bad, it gets much worse. There was recently a warning from Dark Sky International and the American Astronomical Society about two satellite constellation proposals which threaten the night sky. One is Reflect Orbital. I'll tell you a little bit more about that. And SpaceX, which is totally nuts, wanting to put data centers in orbit, which may sound great, but a million satellites, it's a horrible hit for the night sky, for astronomy for sure. But we're going to be losing the night sky. And there have been proposals already from people saying, well, we should abandon ground-based astronomy, just move everything to space. And of course, that's very nice to say, but this is so the cost, pardon the pun, is astronomical. So it's a ridiculous idea, and it has received the attention from past American Astronomical Society presidents that it deserves, and they came out so very strongly against this. Oops. Reflect Orbital that I mentioned, they want to put satellites in orbit to reflect sunlight down to Earth. And with a beam of 5 kilometers in width, and their mirrors would be 18 meters in diameter. And they claim they want to provide sunlight on demand. And the number is unclear, but about 16,000 is the size of their constellation. They say the beam will be precise and uniform and dynamic, so that they can reconfigure their beams as the satellites pass. And these are low. This is a 600-kilometer orbit, so the satellites move very fast, and they're above you only for minutes at a time. So you need more than one satellite to be pointed at your spot. And this, of course, they say you don't need any ground infrastructure to provide this light. But the cost is going to be ridiculous. And one of the things they said was that they want to provide light for solar farms, so to generate electricity. And unfortunately for them, I just calculated how many satellites they would need, and it's just impossible to provide enough light for solar farms with their idea. It's just totally crazy. Besides being absolutely incredibly expensive. Going back to Alan, artificial light at night. Of course, indoors we need light at night, but outdoors the problem is a global problem where the United States, North America, and Europe have lost the night sky for sure, and places in Africa and Ghana here it doesn't look too bad. Accra, I'll show you what Accra is doing in terms of its brightness. And I'm about here on the map, if you see my cursor, and I am from here in Uruguay. That's where I am from originally, but I've been in this country for many years now. So Alan is increasing continuously at an increasing rate, unfortunately. And you can see in Africa, there's a lot of increase in light pollution. In North America and Europe, well, North America, this shows a fairly low rate of growth, but we're already so bad that it doesn't matter. And similarly for Europe. Alan affects biology, as we know. When I was working, I worked for 20 years here in Arizona at the Whipple Observatory, and I was concerned with protecting the sky for astronomy. But it's clear the dark sky is required to maintain the circadian rhythms that we and everything in the environment requires for its survival, for its So anyway, this shows this graph shows the photopic sensitivity, that what we can see during when you're looking at bright light, and the sensitivity at night. It's very if you have blue light, it's the worst thing you can do. I'll tell you more about that. So facts about light pollution. 80% of the world lives under light polluted skies. That's not from those maps I showed you. That's no surprise. The Milky Way is hidden from 1/3 of humanity. I've had people come to visit here from say the East Coast, and they look up and see this strange cloud above, and they ask what it is, and they've never seen the Milky Way. And children are growing up without ever seeing the Milky Way. And 88% of Europe and half of the US experience perpetual twilight, which is a crying shame. And as I showed, the night sky is getting brighter. This shows how how many stars you can see, and the number of stars you can see is going down rapidly, unfortunately. And it's not going to stop, but we're going to do our best to mitigate the effects of that. In an average year in the US alone, outdoor lighting uses it's a ridiculously high number, 120 terawatt hours of energy, mostly to illuminate streets and parking lots. And that's enough energy to meet New York City's total electricity needs for 2 years, which is, this is impressive to people here in the US, but I think it's striking for anyone. And Dark Sky estimates that at least 30% of all outdoor lighting in the US is wasted, mostly by lights that aren't shielded. But also from light that's when you shine light down, it's reflected up, and maybe up to 20% of that is reflected up. So that adds up to about $3.3 billion, and the release of 21 million tons of carbon dioxide per year. We'd have to plant 875 million trees annually to offset that, which it's probably not going to happen. And finally, light pollution contributes to the climate emergency that we're undergoing. Right now here, the temperatures are in southern Arizona. They're this week are going to be in the 30 something Celsius, 35, which is ridiculous. It's usually it's still winter for another week, but we need to address this in as many ways as possible, and reducing light pollution is one way to reduce the impact on climate change. There are some good things that are being done. For example, and 10 years ago, and here in Tucson, there was a successful intervention. They decided to change all their bad street lights to LEDs, good LEDs, and I'll show you a graph later on. But on the left here, you see in June 2014, the sky from Mount Lemmon, which is right next to Tucson, and then you see the sky after after they finished retrofitting all their street lights. There was a 10% of the brightness and decrease, and the total light from the city measured from orbit decreased by 7%. We have satellites that can measure this, and I'll tell you more about that. So this was a successful intervention. Things can be done at significant scales that they affect light pollution significantly. And
sorry, just a moment. Sorry to interrupt, Prof. Emilio. Someone's got their hand up. Did you want to take questions as you go through, or?
Oh yes, I was.
Or should we wait till the end?
No, if you wish to ask a question at any time, please raise a hand, and I'll try to answer. Do you have a question?
Okay, thank you. Benjamin, you have your hand up. Yeah, it was someone called Benjamin has the hand up. Yeah, please.
Yes, thank you very much. I'm Benjamin, and the two previous slides made mention of 1/3 of the population actually not being able to see I had the previous one. Go back again. Yeah, can you please go back again? Yeah. Where it mentions that 1/3 of the population, 1/3 of the population do not actually get to see the galaxy, the Milky Way galaxy.
Where was that? Oh, here. Yes.
Yes, exactly. So I wanted to know, is it possible to view it from the Earth? And if so, what is actually contributing it or contributing to 1/3 of humanity not being able to view it?
Well, it's what I was talking about, this Alan, and light pollution, because light that shines from below brightens the sky, so you lose any contrast. So that's why you can't see the Milky Way. And you see this graph shows this is the number of stars that you can see, and it goes down significantly, and uh, it's the effect, it's the exclusive effect of light pollution. That's what we're trying to address.
Okay, okay, thank you very much. So does this also mean that the reason why we get to see less stars nowadays is as a result of light pollution? And for that matter, if we want to see more of the stars or a glimpse of what the Milky Way galaxy may look like, then we need to get into an environment that has more dark areas. Is that what you're trying to say, please?
That's exactly it. And it makes sense, right? You have to, if you move to, if you're in the city, you can't see the Milky Way. You move away from the city as far as possible, and you start seeing more and more stars, and eventually you are able to see the Milky Way, assuming you can get to a really dark place. But being able to expand those dark places of darker. This is not about eliminating lighting, because if you want to have activities at night, we need light. There's no doubt. But it's about the use of proper lighting. And I will give you a recipe for proper lighting at the end. I hope we'll get there.
Okay, thank you very much.
And okay, my pleasure. Um, so many places, including in the area where I am, we have outdoor lighting codes, and they're essential to try to control light pollution. And of course, the other side of the coin is enforcement of any lighting code, and that's where there are problems. Tucson is renowned for having had the first one of the first outdoor lighting codes, if not the first. And it's the code has evolved, and unfortunately, it's now old. The latest version is from 2012. We're working with them to try to update it, because it doesn't take into account the evolution in lighting technology, which is critical to do. But this shows where we are. This is Tucson here, and you see these circles. They're circles where centered on observatories. Where I used to work is here in the Coronado National Forest. This little section here is in a different county. It's Santa Cruz County. Up here is Pima County, and so we have different lighting codes. But the observatory is here, and these circles show the areas where they have the most protection. This is from a circle that's about 12.5 miles, centered on the Whipple Observatory. And you cannot have any unshielded lights, for example. And those requirements start to relax a little bit, but they still require shielded lights and so on. But here in as part of the Southern Arizona chapter of Dark Sky, we constantly get complaints from people who say, "My neighbor is shining a bright light into my bedroom," and that's called light trespass, and that's not supposed to be allowed. But unfortunately, uh, it's the enforcement is where the problem is. And of course, it's better to try to talk to your neighbor first and see if they can agree. But sometimes they won't agree, and they have mechanisms to lodge complaints, but they're rarely addressed to satisfy people sufficiently. That's one of the problems, the lack of enforcement. And here where we are in Santa Cruz County, we have a very good outdoor lighting code. It has the benefit that the county, it's a small county. It's about 50,000 people. So I know everyone who is an official that has to do with planning, and so we managed to get them to adopt an updated lighting code 2 years ago. No, last year. That's very good. And we're beating the county to our north, which is much bigger and brighter, of course. So for our chapter, our priorities are four essential ones: public policy, working with Tucson and Pima County. Tucson is in Pima County, and they have they share the outdoor lighting code that's being updated now, and we're working on with them, but we're getting a lot of resistance from developers, who are the biggest offenders in general for light pollution. And we're also working on measurement, and I'll tell you about my pet project called the Dark Sky Network. And we have this Dark Sky International has this program for international dark sky places. Tubac, as I mentioned, where I live, and some other locations nearby. Bisbee town to our east received the designation, and Sonoida to our east also is. I'm working with them for their designation. We also work on education and outreach, presentations, partnerships, for example, with the Audubon Society and many other environmental organizations, presentations. Well, here we are. So let me show you now what I mentioned earlier about these satellites that allow us to measure the light issuing up towards the sky from the ground. There's this great satellite that NASA has and they have this program called VIIRS, Visible and Infrared Imaging Radiometer Suite, which gives us visible light data of the light pollution, essentially. And this is extracted from this VIIRS satellite, and it's the radiance from Tucson from 2012 to 2025, and there's a significant variability, and it's due to corrections for atmospheric effects. But you can see, and then this is in units of nanowatts per square centimeter per steradian, but never mind the units. Just remember 100,000 was the level until 2016. Then you see the effect of the retrofit of the street lights. You see a significant decrease. Here it looks like 20% decrease, and it plateaued for several years, but then it started rising again. It's now back to where it was in 2016. And why is that? Well, it's just growth, and a lot of it is commercial lighting, outdoor lighting. And this is Accra. I looked at Accra for comparison, and you can see Tucson has, let's say, 1 million people, and Tucson started at 100,000, and Accra has been rising. They didn't retrofit any street lights, of course, but now they've risen to about 3 times what it used to be. But the level here is 300,000. So I think the population in Accra is about 3 times the population in Tucson. So that correlates with what you'd expect from population growth. And this is what you get at an observatory, where it's a dark sky. This is the Fred Lawrence Whipple Observatory, where I used to work until 2020, when I retired. And you can see, remember those numbers, 100,000. This is 0.1. Now this is dark, really dark. Here you can see the Milky Way for sure. But um, the problem with the light pollution is that it's an evolving target. So we came up with the idea of measuring how much pollution there is, light pollution there is. So we are trying to measure the anthropogenic, fancy name, sky glow, over a long time baseline. We started this project last year. We got funded last year. And so we're trying to distribute sky quality monitors, which are inexpensive, relatively inexpensive, a few $100s. And these photometers tests, these are made in Europe, actually, in Spain. And they have similar properties, but they have a slightly different bandwidth for meaning that they look at the slightly different colors of light. They include more blue than these SQMs. So we started deploying these SQMs, and they're already in place. And I'll show you what we're getting from them. And some of these can be just standalone data loggers with a solar panel, so they can be by themselves, and but they need to have their data downloaded manually. Someone has to go up to them and connect their laptop to them and download the data. But some of them are connected to the internet, and so that makes it much easier. And I'll show you some examples of the data we're getting from these. Just to give you a reference, this is our area that we consider southern Arizona. Here's Tucson, and here's Phoenix to the north. We excluded that monster in lighting on purpose because we don't want to have to deal with so much light pollution. But and this is our area, region of interest, this within the red light. And to the south is Mexico, of course. And we also are working with Mexico with trying to add some of our sensors around here in Mexico in areas that are very dark. This biosphere reserve called El Pinacate, which is a great place. And to the west, of course, you go to California and etc. And to the right, it's New Mexico. So these are those detectors that I mentioned with a solar panel, and it looks maybe cheap, and that's why it is cheap. But they're very robust. They're essentially the worldwide standard for these kinds of things. The detector sits inside this container, and it's looking at the zenith. It's essentially a 1-pixel camera that takes readings every few minutes of the brightness of the sky. And I'll show you what we get. And these are the tests, the units, the other units I mentioned. They look maybe not as cheap. They're not as cheap, but still reasonably priced. And these have interesting properties. That they use Wi-Fi for connecting, for sending their data to a network. So if you have Wi-Fi access, that's what you can use. But of course, it's not possible everywhere. I thought I'd show you. If you'd like to go to this website, we can do that now, or we can do it at the end if you like, to show you a complete description of this DSN thing. But rather than doing that right now, let's show you some results we're getting already. And this funny plot, it's kind of busy, but it shows data for a place that's to our east. It's on the Chiricahua Mountains. They have two sensors there, and they're called Sugarloaf and Bonita. Um, and the blue and green show the actual readings from an SQM that they have at both places. You can see it varies quite a bit, and you might ask why is that? And that's because of the passage of the Milky Way overhead. The yellow trace shows the latitude of the actually the zenith, the distance to the zenith from the center of the Milky Way, and you can see it tracks very well with the blue and green trace. And as I said, it's the increase in brightness is due to the passage of the Milky Way. This is something you have to take into account, of course. But the most interesting thing about this is they've had these sensors since 2017. So it's a long run of data, and this is what we want to achieve with our DSN overall. But one thing you can see is if you look at this red trace here, that's the solar flux in the radio wavelengths. And you can see it increases. The solar flux varies. It goes along with the activity and for on the sun's surface of solar sunspots, for example. And you can see it's been it went to a peak in 2024, 2025, and you can see that the brightness of the sky it also tracks with the brightness of with the solar radiation. So it's something you can measure, and you have to expect the sky gets a little brighter when the sun also gets brighter in the radio. So it's something we have to take into account. The sky brightness is a dynamic thing. It's what we call sky glow. It's quite variable, and it's mostly dark when dark places, but it does vary quite a bit. And this is some data from the data we've collected so far with our sensors. This is southern Arizona in the outline, and we have relatively few sensors. So this is an interpolated map, color map that does its best to show how the brightness of the sky. And as we add more sensors, we'll have a much more detailed map. But you can see already that, of course, I run Tucson here. It's fairly bright. And this one down here, where 14 here is where I am. This is my own sensor right outside my window right now. And you can see it's relatively good. We have Tucson to our north and Nogales, both Arizona and Sonora, Mexico to our south. And they have very bright light, what we call light domes. So the key takeaways are light pollution is just another form of pollution, but it's the easiest one to control compared to, say, water pollution or air pollution. You just turn off the lights or use shielding, or I'll show you more details about what should be done. And Alan is a significant environmental and health threat. It turns out our health is also affected by light at night, by Alan, because, I can't tell you exactly why. I'm not a biologist, but it's clear that we do need our circadian rhythms to live for our life. But losing the night is not inevitable. So we're taking on new challenges. So this is the recipe for responsible outdoor lighting. Use only when it's useful, when it's needed, only if it's needed. There's no reason to light up, for example, a parking lot throughout the night when there's nobody there. Use targeted light so it falls only where it's needed. So by using shielding and careful aiming to target the direction of the light beams, so it points downwards and does not spill beyond where it's needed, so it doesn't produce light trespass. Low level, the light should be no brighter than necessary. It's all too easy to buy light LEDs that are too bright. So you have to consider using the lowest level possible. Controlled, use it only when it's needed, as we've been hammering away. You shouldn't light up areas that don't need light at night. And finally, use warmer colors because, as we discussed, blue light is the worst threat. That's why blue light scatters the most. That's why the sky is blue. And we want to avoid that as much as possible. And I think that's the end of what I had. So if you're still awake, if you have any questions, please let me know. Yes, Jenny.
Yes, thanks for the illuminating talk.
Oh
Can
no.
you go can you go back to the map? I was quite interested in the map.
This one?
Yes, exactly. Yes,
Yeah.
exactly that one. You said that it's an interpolation how the night sky looks like based on the sensors that you have.
Right.
But I mean, I'm just wondering, is this I would say a bit more optimistic because when we saw that Phoenix is to the north, and I mean, I would expect that the entire map is still, I mean, showing green or even orange
Yeah, this excludes
areas at the north.
right. This
Yeah,
excludes. This is we're assuming Phoenix doesn't exist here. So yeah, so you're absolutely right. If we weren't to include Phoenix, you get a horrible blotch of bright light, yellow and red up here. But this excludes Phoenix, and we don't have any sensors in towards Phoenix, so. And maybe we should consider that in the long run. But for now, we're concentrating on southern Arizona, and so this is what we have. Yes, but you're right.
so that so then I was wondering, how do you do this interpolation? I mean, couldn't you set any boundary conditions on the borders to say, okay, we expect at least this and that amount of light? Because here it looks like that it doesn't exist, so you set it to 0, I guess, instead of some kind of like constant estimate or so.
Right. Well, the only point of this map was to show what our sensors can do and are measuring. So I didn't, and this is all preliminary. In the end, yes, we'll probably have to do exactly what you're saying. Add what the technical term boundary conditions to the north and to the south and to the west and to the east. So to include every possible source, yes.
Or just get more sensors. I mean, that would be even better,
Yeah.
I guess.
Get more sensors, but we have limited funding, so we can't
Yes.
put sensors everywhere. But and also we don't have enough people to run this. Essentially, I'm running, and with a couple of other people, we're running this. So even just going to these remote places to install these sensors can be a challenge.
So, I mean, that brings me to my second question. I mean, how many people would you need, or how much work is it to monitor all of this? So, thinking about Ghana, for instance, I mean, what would it take in order to transfer what you have done here in Arizona to, let's say, Accra and surroundings?
Well, I developed software that can be used anywhere, and let's see, maybe we can do this. Where did it go? Hold on. Let me go. So this is that website I mentioned that describes our Southern Arizona dark sky network. And it was somewhere in the presentation. I can put it in the chat if you'd like the link. But well, here is again is our map of sensors, and the software that we use. Let's see. Bear with me for a second. So this is our main website, and you can look at the different sites, and all of this is this shows, for example, for the Sugarloaf site that I mentioned earlier, the variation in the brightness of the sky for a period. You can select a period, but for several months. And you can see we also, of course, we're affected by clouds. Down here, the yellow trace shows our estimate of cloudiness, which causes variations in the brightness. Well, I'll show you. See this choppiness here is due to clouds. Anyway, this is a software that could be available to anyone who wanted to do something similar to what we're doing. And so we'd be happy to share anything with anyone anywhere.
Thanks a lot. So let's see whether there are more questions from other people.
Yes, and any other question? Yes,
Tanaka has the hand up.
Tanaka, yes.
Hello, is it clear?
Yes, we hear you.
Oh, perfect. So, well, let me start by saying good evening once again to Professor Emilio Falco, to the distinguished members from the astronomy field, and of course to my fellow Africans. All protocol briefly observed. Let me just start by saying thank you again for tonight's discussion. It was enlightening, as was said before, and it was particularly interesting to see that something we often view as a sign of underdevelopment is actually a blessing in disguise for our astronomical research here on the African continent. Now, as
Tanaka,
someone from the
excuse me,
tourism
Tanaka,
industry,
are you in Ghana also?
no, I'm joining from Zimbabwe.
Zimbabwe, okay. Just it's great. We have so many people from different places. Anyway, please continue. Sorry to interrupt.
No, that's all right. Thank you. So, as I was saying, as someone from the tourism industry, I actually wanted to highlight that Zimbabwe itself actually has some very amazing regions, namely Nyanga or the Matopo Hills, for those who've been there, which are actually very great for astrotourism. Now, my question was, what steps could we take to certify some of these areas as international dark sky parks? And what could be some of the possible benefits that they have for local communities there?
Well, the local communities benefit tremendously from astrotourism, and that's a big deal here in southern Arizona. It was one of the reasons that we got our designation as a dark sky community. But and for example, for our area, during the summer it's very hot, so that's not when tourists come. But if they come for astrotourism, they need to spend some time in the area. They'll stay, and so this prolongs our tourism season, the astrotourism. But anyway, to your question, really, I would recommend that if you would like to get the details, I can show you how we did it for our area. And in our area, there's also a park called Tumakakuri National Historical Park. which got designated as a dark sky park a few years ago. And we work with them closely also. But the website darksky.org is the best place where you can get all this information. But I will be very happy to give you any assistance if you'd like to pursue an application for a designation. I also work with people in South America. I'm from Uruguay, as I mentioned at the beginning, and I'm working with them. They have some astronomers, and it's a very small country, 3 million people, but they have great natural places, like you were mentioning in Zimbabwe. Maybe not as spectacular, but still very nice areas. And we have dedicated people who are working on developing an application for a particular park, for example, right now. So I have an active knowledge of what you have to do, and I'd be very happy to help you.
That'll be splendid. Thank you, Professor.
So do you have my email? I can put my email address in the chat, and you can go send me an email if you'd like.
Absolutely.
I guess the easiest one would be and there it is. Anyone who has questions or requests, please feel free to send me an email, and I'd be happy to try to help you. Maybe we can start. Oh, let's see. The question. I guess Sarah, I think you raised your hand first.
Okay, thank you. Actually, first of all, I haven't seen your email in the chat, but I'm sure it'll come. I have sort of a follow-up question to Tanaka's question. So Dark Sky International, is that like the overall kind of international body that everyone should go to if they're interested in trying to set up a dark body? Okay,
yes,
it's just that one body, and that.
Yeah, it's a worldwide body.
Okay,
well, we call it the mothership.
Okay, great, thank you. And I actually have another short question. You know, you showed that graph of the data from Accra, from the VIIRS satellite. I just wondered if that is that data kind of publicly available? Is that something that I could look up?
Oh, yes.
I don't know, I was giving a talk.
I can certainly show you how to get it. It's in fact, let me see. I have. Oops. Hold on just a second.
I mean, don't mind about going into all the details. But
I'll put up a link for you, but I'll be happy to try to assist you also if you need it. But yes, I can demonstrate.
I'm sure anyone who's from Accra, they won't be surprised at that data because the city is just growing and growing and expanding, right. And yeah, there's no, as far as I'm aware, there's no kind of policies or anything about lights, and so yeah.
Yeah, no outdoor lighting codes. Yeah, that's the most common situation. Yeah, if it's ever becomes possible to try to develop an outdoor lighting code, Dark Sky International also has model outdoor lighting codes that can be used as a reference. Robert?
Yeah.
Thank you. Emilio, I do understand that you're interested in dark sky is, well, I'm assuming it's primarily to do with the fact that you're an astronomer, and that's your main focus, even though you did mention the other benefits of having a dark sky. Now, from that perspective, I'm curious about other things that affect observation. And obviously, it's not just having dark skies. I mean, pollution is extremely important, I would imagine. And in this part of the world, for many months, we have quite a bad haze. For instance, right now we are in the Harmattan season when dust from the Sahara covers large parts of West Africa and impairs observations. So I would imagine, correct me if I'm wrong, that dark sky or not, we will still have impaired observation ability to observe astronomical objects. What can we do about this? I mean, we don't really have very much high ground. I mean, we have a couple of hills a little to the north of Accra. But is there anything you can do to ameliorate this, except possibly also, in addition to having light codes, push for codes relating to pollution? Thank you.
You mean overall pollution, including dust or whatever?
Yes, I mean, I don't think there's a whole lot we can do about the Harmattan, unfortunately. But
yeah.
Unless you have some science fiction suggestions.
Yeah, use lasers. No, I don't have. Unfortunately, I don't have any insights into on other forms of light pollution. But I should say, although I started from the point of view of astronomy for protecting dark skies, I'm most definitely interested in protecting dark skies for the environment, for the whole environment. Because all of life depends on having a dark sky, having the cycle, and in general, I used to go to the Canary Islands, and over there, sometimes they get these huge clouds of dust going over, and that's a very bad problem for them while the dust is up in the atmosphere. But there's nothing they can do. So overall, anything that can be done to address light pollution at any level is useful, and that includes light pollution, of course. And I don't think I can say much more than that. Sorry, I don't have a magic solution. I wish, or a science fiction solution.
All right, thank you.
Hello, just a follow-up. I'm Ziba. I just wanted to ask about I love the presentation that you did about the dark skies and all. I just wanted to know, like, the mission of PRASAG in Ghana that interacts with students and all that. Is there something on your website, like you said, on the dark sky, where we can share with students? I remember quite not long ago, but then it's somewhat long ago, in 2012, we had a light pollution presentation from the observatory, and it was so nice. We came to understand how it affects migration and all of that. How can we now also have that data translated into a student-based one where we can share with the students and also have them think in that order? Because as you said, we want policies change, but it will not be, it has to be gradual. But even the understanding by some people will help, especially with students, high schoolers, university students getting out to go out there to work with the government can also make some changes about that. And it will help. So is there anything that, like a presentation, a nice presentation put together without too much scientific data or like this graphs and all that, where it will not confuse the incoming scientist? It will make it easier for them to understand what's going on. Yes.
I think there are some resources on the darksky.org, the Dark Sky International website, where they have materials for students, for at every level, essentially, that are not that too scientific. I mean, they're accurate, but they don't have too much scientific jargon, for example. So I would recommend visiting that. And if you get stuck, I can try to look up things for you if you send me an email. Sarah, you have your hand up.
Yeah, I just wanted to mention, first of all, hello, Ziba. Just to say, Ziba is one of our long-time astronomy enthusiasts. Also used to come to the Planetarium many, many years ago. So it's great to see you.
Hi, Ziba.
Yeah, thank you.
I mean, there are some nice activities you can do with students. There's called the Globe at Night campaign, which has been going for years. And basically, it's like a practical thing. It's getting, well, anybody, not just kids, anybody, just all you do is go outside and look for a constellation, and then you kind of record how much of the constellation you can see. So obviously, if you're in a very dark sky, you'll see lots of the stars of the constellation. But if you're in a more light polluted area, you might only see 2 or 3 of the stars. And it's like an international thing. Everyone records what they see, and then they basically build up all this data year after year. So that's like one way, quite a simple way to get kids interested. At least so they get to understand, about the sky and light pollution. And the website is very good. It has a lot of explains about light pollution, about constellations, about how to find them. It's very, very good, even if people don't have much knowledge of astronomy. So that's one practical way that
thank you. That'll be very helpful. Yeah.
Yes, I'm looking it up, and I'll put up the link. It is a great resource. I should have mentioned that I was a little too concentrated on more systematic. It's my scientific bias, I guess. But you're absolutely right. Globe at Night is a great project, and it has the great benefit that you don't need any equipment. Just look up and count stars, and then of course it's best to report your results to the website. So and they do have millions of data points, so it's a very great resource. I agree. Thank you, Sarah. So any other questions, criticism, comments? Oh, come on. Everything was so clear.
Thank you very much for this very great talk.
Well,
thank you very much for doing this.
But let's try, maybe we can make this periodic meeting of the minds every few months. Maybe we can have a meeting and see how things are going. And of course, you can always contact me if you have questions or requests. And I hope to be able to see you in person at some point.
That would be great. I think you can stop the recording now.
Yes, I can.
I was just going to mention one thing that I think when we first heard about Globe at Night, and I think there was also a similar project from Connie Francis.
Yes.
And we were talking about it in Ghana, and it happened to coincide with a time in Ghana where we really had a lot of problems with power. We had what everyone calls dumsor, where the light was just going off all the time. So it's like when you start to talk to people about, oh, we want dark skies, it's like, well, we have dark skies all the time because we don't have any light. So it's like sometimes you have to have like a different mindset, which I think I heard you talking about at the beginning, the whole idea of that you're saving energy. So, which of course is actually also very important. If we don't have a very stable electricity supply, then to be able to conserve energy is even more important. So I think for us, I don't know who else is here in Ghana, in case you're sort of thinking, oh, how do I convince people about this? I think the whole thing about energy saving and health and the climate change, those are the things you can use if you feel that people aren't maybe not so convinced about the